Well, let's get rolling because by the time I'm done, we will have picked up a few more. I just want to welcome everybody for attending today. I'm Colette Sizer. I'm one of the organizers behind C-Free, and I want to welcome you to the 6th presentation that we have done in our Getting to Zero series. C-Free is a working group of the Lincoln Green Energy Committee, and that stands for carbon-free residential, everything electric. So if you have missed, let's see, did I switch to the second slide here? I think so. Am I still on my first one? Oh, here we go. If you missed the past videos, presentations, the past presentations, we have videos online. The envelope, upgrading your windows, go with solar, retrofit of the historical home, heat pumps. And today we're doing the builder's perspective on green building, presented by Mark Doughty and Colin Flavin. Flavin, is that correct?
Correct.
And our last presentation will be on clean electric power on May 23rd, presented by Paul Gromer from Peregrine. Peregrine sets up our aggregate program. Not part of our program, but we don't want anybody to forget the electric vehicle show on July 4th. So with that, Scott, I'm going to turn it over to you. Please introduce our guest tonight.
Thanks very much, Colette. Good evening, everyone. Thanks for joining. I'm Scott Rodman. I am a soon-to-be resident of Lincoln when we finish our new net zero and passive house, which I'm very excited about. Given my interest in this area, I feel particularly fortunate to have Mark Doughty and Colin Flavin here tonight to talk to us about their work with modern homes, both in new construction and historic restorations. They have made important commitments to energy efficiency in homes and to addressing the issues of embodied carbon. And their work in historic renovations and restorations is most impressive. They have worked hard to resolve the many inherent issues that many of those projects present as challenges. Given the number of mid-century modern homes in Lincoln, that is something of particular interest to many people in this community. Mark and Colin have worked on a variety of projects. I think as we earlier said, the two firms have collaborated since 2007 or 2008. That's a pretty impressive run. Colin's background as an architect will be fascinating to many Lincoln residents who remember design research. As early in his career, he worked with Ben Thompson, the founder of DR, and has built a very special practice at Flavin Architects in designing modern homes, both new homes and restoration projects. And Mark is happily a Lincoln resident and a principal of Thoughtforms, one of the leading construction firms in the region. Mark has a fascinating background. We had coffee a couple of weeks ago that was just a great experience of talking with Mark about his experiences and so forth. And he's had multiple careers around the world and included time at a major consulting firm and building Thoughtforms into what is a widely respected firm that has built some truly amazing homes. I encourage everyone to visit their websites to appreciate the range of their work and the beauty of their projects. And most importantly, what comes through is their beliefs in the importance of sustainability and the culture that they have created within their firms. With that, I'd love to welcome Mark and Colin and thank them for talking with us tonight. We'll have time at the end for some questions.
All right. Well, thank you, Scott. I'm going to just try and share the screen here. And as I do that, I will give you a quick overview. Let's see if I've got that going. Now, can you all see my screen? Yeah?
Yep.
Great. So as Scott mentioned, we had coffee a little while back and we got to talking about a presentation that Colin and I had given out in Palm Springs at the Modernism conference. And we had talked about mid-century modern renovation and restoration. And as Scott mentioned, given the number of mid-century modern homes in Lincoln, thought that this might be an interesting discussion for this group. We did modify it a little bit to be a little bit more Massachusetts-centric. But I think what I'll do is, and Scott did a nice job introducing us, so I will skip past the introduction and jump right here into the presentation. So Colin, thank you again for joining me tonight, and also for the idea of this presentation to begin with out in Palm Springs.
My pleasure.
So four questions we hope that we can answer today, and then there will be time for questions and answers at the end, so we can go even further if people are interested. But beyond stylistic motifs, what are the enduring qualities of mid-century homes that are worth preserving and enhancing? I think that's something that Colin is very well prepared to talk about and has a lot of experience with. What is the collective good that brings renovation into the updated energy code? So this is where I'll bore people a little bit with some data and some charts, but it's talk a little bit about why we look at renovation as a good thing, not just something about the aesthetic. And then what are the fundamentals of historic restoration versus respectful renovation? And finally, how can a mid-century home be renovated under the new energy code? So we'll dig a little bit into the new Massachusetts energy code and the opt-in code that Lincoln, I'm very happy to hear that was adopted at town meeting. So I'll jump right in and let Colin take the stage here, going into the stylistic motifs and the enduring qualities of mid-century modern homes.
Yeah, thanks, Mark. So I'll give you a little bit of an overview of what I find so appealing about mid-century homes that goes up kind of above and beyond stylistic motifs that we think about, like butterfly roofs and the kind of colorful palette of that time. And it also goes beyond kind of pure energy use, in terms of, obviously any existing building has quite an embodied energy in it that's probably worth saving, but there are other qualities as well, and I'd like to kind of touch on those now. And Mark, if you want to just move ahead with the slide. One of the things that I think I really appreciate about mid-century homes is their connection to nature. And that's not as simple as just a wall of glass, but it's really, yes, often an indoor-outdoor connection, but there's also, beyond visual, you can also walk, in this example, to an outdoor terrace. So it's not just a visual connection, it's actually a literal indoor-outdoor connection. In addition, this house, this wall of glass is facing due south. So it's very smart environmentally as well. So it captures that winter sun, but that overhanging eave blocks the heat of the summer sun. Next slide, Mark. Mid-century homes are very different than most of the homes built today. They're quite intimate in scale. This primary bedroom is actually only 11 feet wide, and it's one of my favorite images to show potential clients of new homes that they don't need giant spaces. And in fact, when the more private rooms are smaller, it encourages the family members to gather in the common spaces. And next, Mark. There's a satisfying sense of structure in mid-century homes, where you see, in this case, the exposed beams of this Lincoln home. And so rather than having kind of applied ornament that you might have seen in the 19th century, one of the ideas or the ethos of modern architecture was to celebrate the structure, the actual bones of how the building is held up. And we'll go to the next. So floor plans are often very clear, and in this plan, shown in blue, is the bedroom wing on the left, and on the right, the common areas of the house. So very clear zoning of the house. It's very helpful for acoustics. And here you'll see in this 5-bedroom home, only 2.5 bathrooms. Typical home, and Mark, I'm sure you can back me up on this, we put as many bathrooms as there are bedrooms in homes. So again, it's a way to economize on the embodied carbon of a home. And next. So I'd like to go through some case studies of what I call respectful renovation. And that's, which would apply to most homes in the Lincoln area that do not have a historic designation. So here we try and restore the home, but without being 100% historically accurate. Here is the up on Moccasin Hill. Here is the Wales House by Henry Hoover, designed in 1957. And this is the post-renovation picture. And go to the next, Mark. This home is a wonderful illustration of the concept of connection to nature. But you'll also notice that there was a great deal of economy in the homes, most of the homes from the mid-century. So for example, that exposed ledge, the house was located below that ledge, and this wonderful set of stairs kind of glides over the top of that rock. So rather than to the expense of blasting that stone out, the architect was really smart to locate the home kind of next to it, where it becomes kind of a wonderful natural feature. The next picture. And here, I think this kind of shows you our respectful approach to renovation. The original home is on the left, and on the right is the renovated home. You can see that we've kept a lot of the ideas intact, obviously the exposed structure, but we have kind of opened up the kitchen to the dining area. Whereas on the left, you can see there's like kind of a partition there. And I think it by adding the suspended shelving, we're still very much staying in the style of the mid-century. And next. Again, the intimacy and connection to nature. And we'll go to the next. One of the challenges in renovating mid-century homes, and many of you may have experienced this, is they often have concrete slabs on grade that are not properly insulated, as we found here in the Wales House. So in this case, we came up with a radiant hydronic floor heat that was placed on top of the slab, and then a new floor placed on top of that. And that solved that terrible damp cold that these homes suffered over the years. And next. And then, of course, the envelope needed to be updated. And in this case, you can see in the left, the very thin roof structure, and on the right, how we added insulation. And a challenge here, of course, is it's that beautiful wooden ceiling. We didn't want to hide that with insulation below. So we had to remove the roofing and place insulation above the structure. And I think one thing that this slide touches on, and Mark will, I think, give us a lot of good data about, is we kept the existing windows in the house. And it's something that Mark and I have talked a lot about, the embodied carbon of window systems that, combined with their durability of the new windows that are often don't last as well as the old ones. And so that's something Mark will talk about, is how do you figure out the cost benefit of window replacement? Next slide. And as part of our respectful renovation, the original house is on the lower right. The garage is in the center, and in the upper left is a new carport that we added. So rather than try and add to a very iconic home, we really try and make a separate building where we can, so that the original house is respected. And I'll take the next picture. And here's the ensemble. On the right is the existing home. On the left is the garage that's been converted to a guest house. And then next slide. And here is the carport that we added with charging stations. And one of the things I love about carports is, in New England, we're often so concerned about the building envelope and thermal transfer. With a carport, of course, you don't have to worry about that. And here we added these wooden screens to kind of create a wonderful lantern glow at the entry to the property. And next slide. How am I doing on time, Mark?
I think we're good.
Okay, great. Okay, and here is the famous Gemishausen house, also by Henry Hoover. And we'll take a look at the next picture. I think this illustrates this beautiful connection to nature. The the house is entered via this wonderful covered walkway that sort of is tracing the original contours of the land. And again, Hoover is able to just really place his homes very delicately on the land and very respectfully. You'll notice the native plantings. There's no lawn. There's no formal garden per se. It's really, this is just sort of what nature brings over the years. Next. Again, a very clear diagram of the floor plan. On the top or in blue are the private spaces of the house, and below are the public spaces. And if in the center, you'll see a room labeled number 5, which we've labeled as the dining room. And if we go to the next image, we're showing here, this was, and Mark worked on this Thoughtforms with us, and this is a completely new kitchen, but it's done really in the style of the original home. And it's also, again, it's a simple galley kitchen and perfectly adequate, but wonderfully crafted with stainless steel and soapstone counters. And next. So here, when I told you to take a look at that center space, so under this wonderful George Nelson light fixture was a indoor swimming pool when the house was originally built and before we renovated. In fact, the pool is still there under this floor. But I think this kind of captures so many wonderful qualities. That bank of windows and doors on the left is facing due south, capturing the winter sun. And I think this photograph was taken in late October. So you're getting that kind of wonderful sun. This was really a labor of love on the part of the owners, who I think Mark and I really appreciated. And Mark and his team jackhammered up this the entire concrete floor to add radiant floor heat. So it was really quite an amazing feat. The next image. And here we are at the lower level. And again, the basement floors were all removed, and radiant floor heat was installed. And just when I first came to this house, it was summertime, and it was just super moldy. And you get, what happens with uninsulated concrete is it's not so much water coming through the concrete, it's indoor humidity on a warm day condensing against that cold concrete floor and causing mold. Next. And here's another home that we restored, the Brown Jackson house in Lincoln. And I earlier showed a picture of this. We can skip to the next slide, Mark. That's that very clear diagrammatic floor plan, just in an L shape. And next slide. Beautifully connected to nature. So here's a view on the inside of that wonderful glass wall to the right. Again, doing so many things well. This is a wonderful design motif that came from California, this idea of moving the kitchen away from the outside wall, hence the term floating, which allows floor to ceiling glass, a glass line to the right. Next image. And I just think wonderfully intimate family spaces. This is no more kitchen than probably most of us need. I also really appreciate this is all completely rebuilt, but we did, keep some of the ideas of original structure. So keeping these cabinetry away from the main structural beams. So clearly it doesn't read as quote structural. Next image. And again, another picture of the dining area, just very informal, I think, but super functional for this young family. And next. Okay, Mark, I think I'm going to hand the baton to you.
Okay, well, thank you, Colin. So at the beginning, the name of the presentation, we said the builder's perspective. And I think what we'll talk about here a little bit is what informs our perspective as builders. And I think the collective good that brings renovation into the updated energy code, but in general, just why we think renovation is a good thing whenever possible. So if you take a look at this slide, the real point here is that there's going to be a lot of construction between now and 2050. 17 billion square meters of new floor area is forecast, and this is some data from the MIT Sustainable Design Laboratory. And if I did the math right, 17 billion square meters is somewhere around 20 square meters every second from now until 2050. But if you look at that 17 billion square meters is actually dwarfed by what will be existing square footage that we have to deal with somehow. And when I say we have to deal with it somehow, that's because if you look at what the climate targets or the commitments we've made indicate, it's that we have about 300 gigatons of emissions that have been allocated to buildings globally. And when I say allocated, this is again part of the model. The models that the UN have worked with have been part of all of the international agreements. If we stay on a business as usual path, which until now has been about 1% renovation per year, and moving toward new construction being all carbon neutral by 2050, we more than double the allocation, or so the allowance that we have to try to keep temperatures from rising more than 2 degrees Celsius. So the only way for us to hit the target in the built environment is to increase the pace of renovation to 5% of buildings renovated per year, and all new construction carbon neutral by 2030. So that's a much more aggressive path than many people are thinking about, or I would say that the average market is thinking about it. But it's something that informs us as builders, and Colin, I know, as an architect, and motivates us to focus on renovation. And why do we focus on renovation? This is a model that's available online. If it's put out by Architecture 2030. And what I did was I just did a quick modeling of 2 buildings. One that is a reuse and addition, so renovating 2,200 square feet and then adding 400 square feet to get to a total of 2,600 square foot home. And then comparing that to a 2,600 square foot new home. In both models, assume the same insulation and energy efficiency. And in both homes, assumed all electric systems. And what you can see here is that you heard Colin talking about embodied emissions or embodied carbon. So you can see here that the embodied carbon for new construction is higher than it is for reuse. And that's primarily because concrete and steel are the biggest contributors to embodied emissions in construction. There's quite a bit of research, and you can jump online and read about the whys, but the most recent data I saw suggested that concrete is responsible for between 5 and 8% of global emissions annually. So the fact that you can reuse existing concrete and existing steel when you renovate a home puts the renovation into a favorable light with respect to emissions. Now, I said that these are comparable insulation and efficiency and all electric systems. Switching over to operational emissions, I just wanted to show why we have been advocating for all electric systems and educating people about all electric homes for a number of years now. You can see here on the left, the reuse and addition now shows a home that is comparable in terms of thermal efficiency, but has a gas-fired system. And the operational emissions here really dwarf the savings that you get from your embodied emissions. So this is really the 2 steps. I think that when I speak with people, the first thing I focus on is really the all-electric home, and then we focus on the embodied emissions. So what's driving those operational emissions? Again, just some data. On the left, this is from the US Energy Information Agency. It's the Residential Energy Consumption Survey from 2015. So the data is a little bit old, but if you look in the Northeast, space heating is responsible for about 56% of the energy demand in a home, and water heating is another 17%. So if you think about both of those are both easily electrified with air source heat pumps for space heating and air source heat pumps for hot water heating as well. The other areas, I mean, yes, we want to pay attention to air conditioning and refrigerators and other here is a pretty big slice. It includes things like hot tubs, wine cellars, and there's a whole basket of things in there that was a little too difficult to break out in a meaningful way. And I think that the real message here is that space heating and water heating are the things that we can focus on with electrification. Now, as we electrify homes or as we deal with the space heating, what's causing the need for space heating? More than a third of the space heating demand is driven by air infiltration, so air leaking out of a home. And when the air leaks out of a home, the hot air rises, leaks out of the home in the winter, and then cold, dry air infiltrates the home and has to then be heated by the home systems. About 30% of the energy lost is through windows. And I think, this is an average home. If you looked at mid-century modern, that slice might be a little bit bigger given the amount of windows you have in a home. And then thermal transfer through the walls and the roof. The thermal transfer through the slab is the smallest piece here. And in some ways, it's one of the harder ones to deal with because it involves either going underneath the concrete or over it. But it's these other areas, the air infiltration is the one that really, even if you don't go down the path of a substantial renovation, if you focus on reducing the air infiltration and you electrify your heating system and your water heating system, you'll make a big impact on the overall emissions of the home. So here I'm going to switch over, hand back I'm actually going to hand back to Colin after one more slide here, because what I want to talk about is when we look at historic restoration and respectful renovation, in either case, we start with sort of a hierarchy of needs here. So the first thing we look at is identify and address the flaws that compromise the durability of the home. If the home's rotting, or if it's somehow degrading through insects, that has to be solved for. As we talked a little bit here about the understanding and reducing energy loads, I just shared the slide which talked about air leakage, insulation, heating and cooling, appliances and lights, and all electric systems. This is not just for energy, it's also for the healthy indoor environment. And one point to make here is we have actually tested homes when people have moved in to test the indoor air quality and ensure that they've been properly ventilated so that there's no VOCs, a really clean home. We've come back, in one instance, we came back a couple of years later and we tested the home and we found formaldehyde and an incredibly high level of VOCs. And this is a home that the client had gone to great lengths to make sure that the indoor environment was healthy. They hired an expert who had all these hypotheses about what went wrong with the construction. And we talked that through and quickly realized that it wasn't the construction, it was actually some of the furniture that had been purchased and put in the home. There was formaldehyde in the plywood that was used in the framing of the sofas. And the clients, because of their concern about a healthy indoor environment, had cleaning staff coming through the house multiple times a week. It was the scent on the cleaning products, so the citronine, the limonene, the pinene, that were increasing the VOC loads. So just a few changes there of making sure that you select healthy furnishings and that you don't introduce through day-to-day life other contaminants into the home. I think this fourth point, the idea that we went back and tested, we measured the home at move-in, and then we went back, as I said, a couple of years later to see what was going on. And we do this with energy as well. We put in monitoring systems because you can plan for a certain outcome, but unless you actually measure, you don't know if you're achieving your goals. And sometimes you'll find things we found on a hot water heater, an air source heat pump hot water heater, that the eco mode, which most people would assume that if it says eco mode, that would be the most efficient mode. It actually turns out that that eco mode would cause the electric resistance heat to kick in frequently on the hot water heater. And the electric resistance, it's kind of the old school, just a wire that gets hot inside the tank. So it was really running in a very inefficient mode. We contacted the manufacturer, went and to troubleshoot it, and they said, oh, no, eco mode is not the efficient mode. The efficient mode is air source heat pump only. So we switched to the air source heat pump mode, and the energy profile on that appliance dropped, I think, an order of magnitude. So a big change, but we never would have caught that if we had just kind of ticked the box and said, okay, we turned on eco mode, everything's good now. So measurement's really important here. So here's where I will turn it back over to Colin. The idea is that in mid-century modern homes, you have durability issues around windows with water leakage, wood materials close to the ground and plantings, very common because of the way they're nestled into the landscape. The energy loads, we talked a little bit about air leakage around windows, the tongue and groove roof decks, the roof rafter and wall intersection, and then at the sill down by the ground. The windows, as we talked about, the single pane windows, there's a lot of heat that's lost and a lot of heat that comes in the summers. Heat radiating through an uninsulated roof in the summer, making the rooms hot, but then leaking heat out through the winter as it radiates outward. Gas or oil-fired space and hot water and hydronic heating. Colin had mentioned mold and mildew are prevalent in the vapor permeable slabs, and also, as he said, because of the condensation in the summer. Then the combustion gases in the living space from the heat, oil heat often in some of these older homes, and then the gas stoves. And also these homes didn't really have mechanical ventilation. The old conventional wisdom was that homes need to be able to breathe. And we realize now that a home that breathes through unconditioned or untreated spaces, if it's coming in through the cracks in the foundation, that's not necessarily clean and healthy air that's coming into the house. So we use mechanical ventilation a lot these days. Measurement was really, it was a crude form of measurement. It's your utility bill, or if you had, it's the number of trips you have to take to and from the basement to clean out the dehumidifier.
I love that.
So here we have, Colin's going to take you through some actual case studies and just point out some of the areas where this hierarchy comes into play.
Yeah, actually, we can move to the next slide, Mark. So I think this will be something you all enjoy. These are, in contrasting the respectful renovation of the projects that I showed you previously, these are 3 examples of iconic buildings or houses in New England that are just deemed so important, either because of the architect's reputation and the fact that the house is so interesting. So starting from the left is the Walter Gropius house that you all know here in Lincoln. In the middle is Philip Johnson's Thesis house. And on the right is Frank Lloyd Wright's Zimmerman house. So a couple things a couple themes that I want to pursue here. One is the kind of challenge of doing modern architecture in New England, and then some of the challenges in terms of how a building is actually assembled that has led to building failures and how they've been fixed in these instances. So let's start with the Gropius house. And Walter Gropius, of course, coming from the Bauhaus in Germany, was enamored with the New England landscape, and particularly he wrote fondly of the wonderful, delicate wooden farmhouses that were throughout New England. So when he came, I think he was quite influenced by what he found here in New England. So you'll notice on the left, his house is a 2-story, simple mass, very much like the Colonial to the right. It has a center entrance, as a Colonial does, and it's clad in wood, although a little bit different in detailing. And finally, they both have sort of a natural fieldstone foundation. The next slide. However, Gropius was never renowned as a fine architectural detailer. And here was one of the challenges that was found when the home was restored by Historic New England. And I should just add that all three of these projects, the restoration engineer was Simpson, Gumpertz, and Hager, and they've just done a tremendous job. So let's go ahead to the next slide. And so on the left is traditional New England detailing, where you can see the blue arrows are the drip lines, so water naturally drips away from the facade of the building. And then on the right is the Gropius house, and you can see the arrow to the right is where the water is actually being brought into the inside of the house. So his assembly was not properly done, and as a result, water was coming in through the windows, and there was not a pan and sill flashing to bring that water back to the outside. We'll take a next picture. Little more detail on that. And here's how it was corrected. The two images on the left show how flashing was added to direct that water back out to the outside of the building. And the diagram on the right, you see that new metal flashing there in the bottom of the image. Next. And next we'll go to the Philip Johnson thesis house, which not many architects have the opportunity to build their thesis project in graduate school, but that's exactly what the wealthy Philip Johnson was able to do. And this is a precursor to his famous glass house in New Canaan. And you can see the kind of wonderful wall of glass shown in the picture on the right. And what Johnson did very cleverly was he built sort of a wall around the entire house to achieve privacy in the urban setting. Next image. Johnson, of course, being an architectural student, he didn't have his technical detailing figured out either. And this house, all the sills of the house rotted out. They were put right at grade. And you can see that excavation and just the deterioration on that image on the left. One of the striking pieces about this house is that glass is single pane float glass, untempered, and the largest piece is 9 feet by 17 feet. So if we go to the next image, that glass they were unable to remove it for the restoration for fear that it would be damaged and broken. And so it was kept in place and the building was basically rebuilt around it. Again, I think Mark will be able to speak to the advisability of keeping single glazing in a home. But I think, there are two elements here. One is the embodied energy that goes into the replacement of existing windows. And the second one is that new windows they don't have the optical clarity of this original glass. So this is, maybe an exception to the rule that this is such an extraordinary example of architecture that it's worth saving something, even if it's not the most energy efficient. Next slide. And here's the final image after completion. And you can see on the left-hand picture that extraordinary 17-foot long piece of glass. I think 3/16 of an inch thick. So it's just amazing. And then the resolved detail on the right. The next image. Here's Frank Lloyd Wright Zimmerman House in Manchester, New Hampshire. And on first glance, I think we could say, oh, this house is doing a lot of things really smart. It's got a simple gable pitch roof to shed snow and water, and it's got overhanging eaves to protect the outside walls from water penetration. But let's take a look at the next image. In the wintertime, on the image on the right, you're seeing these kind of very romantic icicles. But what's really happening there is we're getting ice damming. So Frank Lloyd Wright decided not to insulate the roof cavity. And the kind of thermal drive is diagrammed on the left, where you have warm air on the interior of the house, melting the snow in the roof above, and that snow melting, becoming water, and then once it reaches the eave, it refreezes again, creating an ice dam, and then in turn damaging all that beautiful woodwork on the interior. Next image. And here's the restored house on the right. You can see that beautiful ceiling in its restored condition. I think the next slide, Mark, will show us the detail. Yeah, so the solution was really quite simple, essentially to create a cold roof, as you can see on the simple diagram on the right. So the clay tile of the original house was taken off, and then a vent was placed, sort of a cavity was placed between the original roof and this clay tile roof, so that it remained cold throughout the winter. Next slide. There you go, Mark. Up to you.
All right, so I'll take it back here. And I just want to say one of the things I really appreciate about working with Colin is, as you can tell, he pays attention to the details. So a lot of what Colin just went through in terms of how to fix some of the problems you'll encounter in a mid-century modern home, I think it reflects his investment in learning and understanding how homes work. There's many times where we, as the builder, are bringing that kind of insight to the table. And I think that what's important as you look at renovating any home, whether it's a historic restoration, which we just walked through a few of those, or if it's something that's just more modest, working with folks who understand what it means to get it right is a really important element to success. And so to start, I mean, I think if we just address some common misperceptions that folks, maybe on this call, maybe you've covered it in some of the, well, you have covered some of these things in earlier presentations, but I'll just walk through a few of them here, where one misperception that we see is that, you know, high performance homes cost more. And when I say high performance, I'm thinking, you know, net zero passive house, or homes that just operate in a better way. They have a real modern envelope, mechanical ventilation. The reason that this perception is out there, I think, is because people are looking at old data. Some of it, I believe, is actual misinformation. It's actively being spread. And then another one that's really important is this idea of inexperience. If you don't know how to build a home to a modern standard, then you'll make some of the mistakes that Colin just illustrated with the Gropius house, the Zimmerman house, and the Philip Johnson's thesis house. What the data says on this is that really high performance homes are at cost parity or beneficial in economic terms. We've done in-house analysis on projects on new homes and see a 3 to 5% premium on upfront cost. The Rocky Mountain Institute has done analysis around the country in different markets and found similar numbers. And then the Mass Clean Energy Council has also done that with what does it take to get to a passive house standard, and found that same 3 to 5% premium in terms of upfront cost. The idea is that, however, that if you take into account operating cost, you actually come out ahead. The idea, another common misperception is the idea that electric homes are uncomfortable. And I know when I was a kid, if somebody was heating with electricity, it was electric baseboard, or it was forced hot air. That was, both of those were very uncomfortable systems, and also, I think, inefficient systems. The current technology, I think you're all well versed in the benefits and the performance of air source heat pumps. For an indoor, for the occupants, there's really no way to tell the difference between an air source heat pump, if it's ducted, from a gas-fired boiler or an outdoor air condenser for air conditioning. So the systems really can be transparent to the occupants and be very comfortable. Electric homes expensive, as I mentioned, the electric resistance, it was very inefficient and expensive. So I think that comes from again, the outdated data and old perspective. One thing that we actually hear from clients, but also from some subcontractors, is that this all electric technology is unproven. And I think here it's just a matter of the air source heat pump, I think, was patented in the 1940s, and it's been around for a while. It's just not as familiar to the US market. It hasn't been adopted here until recently, and the technology is well established. Another one that we see people concerned about, induction cooktops. They feel like real cooks don't use induction. And if you talk to professional cooks, which I have some friends who are professional cooks, they have expressed a preference for induction because it's cooler to work around. You don't get burned. There's not a lot of waste heat. You don't need the same kind of ventilation volume that you do on an industrial cooktop. But in that one, I think it's worth, if you have any doubts there, people should just go try it for themselves. And then the final misperception that I run into a lot is this idea that the grid can't support all electric, and that there's an increased risk of power interruption. People look at what's happened in California with the utility out there having problems. But I think what we're looking at here is, it's true, the grid couldn't support all electric if it happened today. And that's where a lot of people seem to be seeing it as an obstacle. And the reality is it's going to take time to move to an all electric infrastructure, and the grid is moving along with the individual homes. So one other thing I thought was very interesting, in where do these misperceptions come from? Some food for thought is the National Association of Home Builders. So this is the industry group. On their webpage, you go to the NAHB top priorities building codes, and there's a statement in there that says the original purpose of codes was to protect public health and safety, but government agencies have increasingly turned to codes to implement other policies such as energy efficiency, resilience, sustainability, and property protection. So just if you take a minute, or these slides will be available after, if you read that and really think about the way it's phrased and what it's saying saying that public health does not take, energy efficiency, sustainability, property protection are not related to public health. And I guess this is why I say it's food for thought. I personally take the position that, as a society, we look very much at the here and the now and the today, and we don't properly take into account future outcomes. And so from my perspective, energy efficiency and sustainability are things that protect future health and future public safety. So I think that it's really how you think of these things. Our system just is overly biased towards the here and the now. Discount rates in finance, they decrease the value that we place on future generations. And I just think, again, food for thought. Jumping into the energy code, the updated energy code. So it really is, it's designed to move things forward in terms of that energy efficiency and sustainability. The new code sets targets for homes. Here, I'm just focusing on alterations and additions. They use what's called a HERS score. So if you're not familiar with that, it's the Home Energy Rating System. It's a model that incorporates building elements, systems, and performance. So it looks at, with respect to building elements, it's the insulation and the windows. Systems, it's the mechanical systems, the heating systems, the mechanical ventilation. And the performance would be looking at the air infiltration on the home. It compares what's going to be built, what's modeled, to a baseline of a 2006 energy code compliant home. And then the score approximates the percent of energy used relative to that reference home. So if you look on the left, you see like the number 52, that would say that the new code requires a home to be built to use approximately 52% of the energy of a home built in 2006 to code. So what the new code does is it biases people toward solar installation, all electric, because you have a higher HERS rating, or you're allowed a higher HERS rating there, which means you can get away with a little bit more if you want to think of it that way. If you use fossil fuels in the home, you have to hit a higher standard, which is a little bit more expensive in terms of what you'll have to build. And I think that it also, it just, in terms of the idea of going all electric, it doesn't solve some of that operational energy problem that we illustrated before. So the updated energy code, so I'll talk a little bit about the updated energy code, because it doesn't apply if you're going to be repainting rooms, putting in new floors, or just some limited renovation. You won't be triggering the energy code. So that goes back to the idea of the hierarchy we were talking about, is first focus on durability, then focus on the energy demand and working through it in that way. But if you do trigger the energy code, you really don't have a choice but to go through that hierarchy and go through it very aggressively. So what triggers the energy code is going to be additions over 1,000 square feet, additions that more than double the conditioned floor area, and then an addition or a renovation where over 50% of the home is renovated and reconfigured. So renovated and reconfigured, the common interpretation of reconfigured is that it's moving walls and changing the floor plan. So the renovation that Colin showed that we did together on the Germershausen house, that would actually not have triggered the energy code in this instance. So exemptions also can apply to historic properties. So the Gropius house, for instance, the Philip Johnson house, those are both historic properties, and those would not be held to code. However, if you won't be renovating them in ways that would trigger the code in general. So what would it take to achieve code required HERS rating if you really were to try to take the Germershausen house up to current code? And this, I think, would apply to most mid-century modern renovations if you were trying to hit this new code. You'd have to focus on air sealing. A very target of 1 air change per hour at pressure of 50 pascals is a pretty high bar to clear, but it's possible with the peel and stick membranes on the roof deck and on the sheathing, and a lot of handwork, and a product called Aero Barrier. So on this slide, again, this will be available afterwards. You can dig into it a little deeper. The real idea is that you'll have to do a lot with air sealing. You'll have to insulate the walls, probably from the inside and outside with a continuous insulation. Your windows, Colin had mentioned the embodied energy on windows. I think that the math works out that the home will be more efficient if you upgrade to a triple pane insulated window unit and thermally broken frames. One thing about windows is a lot of times people, they think that the house is drafty because they feel drafts near the windows. And what you're actually seeing is on single pane or large double pane windows, you're getting cold air at the window that's dropping because it's cold and it's heavier than the warm air. And as that cold air drops, you feel it down near the floor, and then warm air rises, and you actually get a convective current because so much of thermal loss through the window. Moving on to other aspects that you'll need to address to hit the code. Continuous insulation on the roof, on the exterior of the roof, and Colin had showed a slide where that was done. And I think one of the things that's nice is that can be done pretty easily on a mid-century modern home, and it can be done in ways to minimize the impact on the aesthetic. The systems, I think if you were doing a renovation of mid-century modern with the idea of you were going to have to hit the code, you would likely go to solar plus all electric, so that you'd give yourself a HERS target at 58. You'd have to introduce mechanical ventilation, which is required by code, but it's also, I think it's the right thing to do to maintain the health of the indoor environment. And you'd possibly have to upgrade the electrical service to accommodate the all electric load and the electrical vehicle charging if you wanted to add an EV. We've seen some homes in Lincoln and other areas where they're still running on 100 amp service, which is not enough for these all electric homes. And then the slabs, Colin talked a little bit about the things you can do to make the slab performance better. And you may be required to do that if you're trying to take a home up to the new energy code. So one thing I just thought is kind of interesting is that going back to this idea of, what does it look like? How does it impact the aesthetic? A couple slides here just well, this house, is it high performance or is it all electric? And the question here is, can you tell? This one has a gas stove. Apart from that, it's all electric. And it is, I would say, a high performance home. It's not net zero, but it would meet the current code for new construction. And it would hit the required HERS rating. This home here, high performance or all electric. This is actually our home. It's net positive. So we generate about 70% more energy than we use, and it is all electric. And it's the solar array on the front of the house that generates the energy that makes us net positive, along with triple pane windows and a well-insulated building envelope. And I think what the point here is that this doesn't look like, I don't think it screams out that this is a net positive home. And I don't think if you look at the interior, you would say, oh, there's a lot of compromise being made to pursue some sort of an energy objective. Here, another one, high performance or all electric. This home, it was targeting net zero. I think it's running a little bit over, but it's been pretty close. Again, big windows. So here you can see that, a high performance home doesn't mean you have to forgo windows. Here is another high performance or all electric. This home actually uses ground source heat pumps. So a lot of people refer to that as geothermal, but it's using the ground as the heat source instead of the air. And this home, again, very well insulated and extremely high performance mechanical ventilation. The client here was very concerned about the indoor air quality. So summary here, just to try to close this out, renovations provide many benefits. I hope we've made that point, and renovations come at different levels. Energy and health are key considerations in the renovations, whether you're trying to hit the code or required to hit the code or not. Energy and health does not equate to compromise on aesthetics and quality. That's, I think, it's been an obstacle for some people, as they think that it's going to lead to just a compromised aesthetic and living experience. And I think that's not what we're seeing in actual practice. And then I think the fourth one here is that the market, it's evolving rapidly. And I think if you're going to be looking at any level of renovation or upgrades to your home, you need to be curious, you need to do your homework, and you need to seek out partners who are focused on the future. And my closing comments on that are, there was a study done in 2018 that compared HERS ratings. So it brought a number of different HERS raters to a number of different homes. And it showed that there was a huge variation in the actual HERS rating that was given by a licensed HERS rater. And some of that variation was due to people not paying attention to simple details, just things like the color of the roof, which is an input that goes into the HERS model. And I think that if you're really trying to achieve an objective, partnering with people who are aligned with your way of thinking and they're curious and they're trying to achieve results and verify results, I think it's important, whether it's your architect, your builder, your HERS rater. And there are a lot of folks out there that are not paying attention or are actively trying to slow things down. So I think my closing point would be, please, thank you to the folks who are hosting this for bringing this forum together. I think it's community connection and people understanding what's out there as options and trying to inform and educate others so that we all understand that this is a positive direction to move, and that we move there together. So with that, I think we've hit our 1 hour. So I'll turn it back to Scott and the host to see if they'd like to take a few questions or if we should close down here.
Mark and Colin, thank you so much. That was a wonderful presentation. It's incredibly helpful. It's amazing how you brought all the components together, and I think that's what's needed to have people hear about systems and building science and so forth, and the idea of what you can do with renovations and the careful restoration. Are there any questions that anyone wants to ask? Michael.
Yeah, excellent presentation, Mark and Colin. Really, really, really cool stuff. I live in a deck house. I did a lot of air sealing myself, and then brought in a pro who did air sealing with a blower door active, and we just couldn't get our air changes down below about 5. And I finally concluded that it's the tongue and groove roof deck. Now I've got a lot of insulation on my roof. I ended up with 7.5 inches of polyiso on it. So I don't think it's likely that the air leakage is going up through all those layers of insulation. I think it's more likely it's getting into the grooves and then going out the ends of the building, which could happen on both levels. Do you have any sense of this, or how have you dealt with tongue and groove roofs?
So that's a really good question, Michael. Is like, what is the path that the air is moving, right?
Right.
And I think that question, I can look at it on a tongue and groove roof, and I can look at it on all the buildings that we've renovated. And I think that the way that you find out what's going on is similar in both cases. What I would suggest is that you get a blower door and you pressurize the house, you positively pressurize the house. And you do it, so you do it when it's still cold out, and you crank up the heat in your house so that it's almost uncomfortably warm. And then you positively pressurize the house, and then you go around with an infrared camera on the outside of the house. And you could very quickly look along the rakes of the roof and see if your hypothesis around the tongue and groove being the source of the air leakage holds, or you might find that there's other areas that you could quickly go back and address. I think getting it below a 5 ACH 50, it's probably an achievable target, but you need, you have the tools. You need to know which direction to point.
Yeah. Okay.
Does that help, or are you going to tell me you already did that?
Well, we did pretty much that. I mean, we did it on cold weather, and he had his camera inside the house. I think he was depressurizing it, but he was looking for places where the air was, cold air was coming in. And so, I mean, I do have a little bit of empirical evidence that one morning I went out to check on some areas that I had used a thermal camera on the night before. It was like 17 degrees out, and I'm at the end of the house looking up at the rake, and I see frost forming on the ends of the just behind the fascia. And my wife had just taken a shower in a bathroom it's a full room away, but I'm guessing that the moisture went up into the decking above the shower, went all the way, probably 20 feet, and then came out the end of the house, and I saw the frost there. So, I mean, it's a teeny tiny bit. I don't know if there's enough volume there, but it made me suspicious.
Yeah, if you're seeing a teeny tiny bit, what we've found is when we've gone back to look at some problems in homes, you don't always get a big tell, but if you're able to see something behind the fascia with a thermal camera, I think with that positive pressurization, you do tend to really emphasize where it's coming out on the outside. And often on a home like a deck home, dealing with it from the outside will be a more cost-effective way to deal with it. Because if you were to use something like Aero Barrier, which is a product that's going to have a visual impact on the inside, and you don't want to have that aesthetic. So I think that if you tried positively pressurizing it, and you don't have to stop at 50 pascals, you can really crank up the pressure.
Gotcha. All right. Cool.
Mark, one comment you made about Aero Barrier, which I've always been a fan of Aero Barrier. Can you just describe it briefly? And also, one of the comments is I've often thought if somebody sold a deck house in Lincoln and it was empty, and somebody was coming in to do basic renovations, be a perfect time to do a test case of an Aero Barrier project on a deck house. Yeah.
So, I mean, Aero Barrier is it's for those who aren't familiar, it's a product that you vaporize latex. I think it's actually a latex product, but you vaporize it, you positively pressurize the house, and the vapor collects and builds up in cracks. And so it seals the cracks. I mean, I don't know if we were having a little chat about cycling before we went live tonight. And I don't know if anybody has tubeless tires, or but it's the same idea. You have something that fills holes through a latex buildup.
Michelle, you had a question?
Yeah, it's actually not unrelated to Jennifer's comment in the chat. I think one of the things I've been most struck by in this presentation is just this idea that we need a 5% renovation rate versus a 1% in order to reach that 300 is it gigaton, I guess, CO2 goal. And I forget if it's by 2030 or 2050, sorry. But anyway, in the context of housing shortage, and with that 5% goal in mind, I just wonder whether there are developers out there looking for single family resident homes that they can make into multifamily using that same footprint of the same house, making just smaller spaces, which would be more affordable, but would also, help create housing and would help get towards this goal of 5%, 5% renovation versus 1%. And I just wonder if there are any developers out there that you know of that might be thinking about that.
So the short answer, I don't know specific developers who are working on that. I think what I've been thinking about to address this 5%, and I'm going to go out on a limb here because we build beautiful homes, and we're very fortunate to be in the Boston area where people are willing to invest in craftsmanship, and really people investing themselves in building high quality and beautiful homes. But every day we observe the economic inequality in our society, and we see, there's a desire for all of us to roll along without having to change our way of life. And so there's this idea of carbon offsets. Okay. And I can fly to Australia to go surfing and then pay somebody to plant some trees. And again, I know I'm going out on a limb here. And I'm not indicting Colin here. This is me speaking. And I will speak officially as a Thoughtforms representative, but I think when I've looked at carbon offsets, the idea that I've been talking to some people trying to think how to make it happen would be, there are people who can't afford to renovate their homes. And I think, Michelle, this is what you might be getting at, is the housing shortage, but just people who have a house but can't afford to update it and make it efficient and make it healthy. And if you think
they
about
need a developer.
Yeah. And if you think about a carbon offset needs to be durable. It needs to last 100 years to offset carbon that we're putting into the air now, because it's going to take 100 years that carbon is going to be up in the climate for 100 years. So if you plant a tree, that tree is going to have to be watered. It's going to have to be taken care of. It's going to have to survive forest fires and all these other things. And it's probably in a monoculture situation. I'm not sold yet that that's the solution. I'm much more inclined to think that if there was a way to take some of the money that's going to carbon offsets and put it into renovation of homes for people who can't afford it themselves and get those homes set. Now, I know it doesn't increase the housing stock. And this is something I spoke at a conference and tied it to the idea of how do you pay for that? And I think that as a society, we talk about life, liberty, and the pursuit of happiness. And I think we've over-indexed on liberty and the pursuit of happiness. And we've lost sight of the idea that life is part of that trifecta. And I think if we put more into community service, national service, where there's a climate corps, and you have people who for a year they finish high school or they go to college and they have to go out and work in renovating homes. It's a big lever we can pull. So that's like, I know that's not the developer, that doesn't answer your developer question, then I'll stop.
No, but it's basically, it gets at what I was driving at. is that, you know, especially in Lincoln, you've got a lot of elderly people. They don't necessarily need 4,000 square feet anymore, but they don't want to move, but they can't really afford to make it into a duplex. But
Right.
if there were a developer around, or if you could sell carbon offsets that are basically, instead of forests, are you know, part of this green renovation of existing housing stock to help finance it, or I think, yeah, you're getting at my point. Yeah, exactly.
Yeah, I think that, I mean, I think that that's the thing, is that the conversation needs to go to a higher level. And I think it's community organizations like this that are going to solve some of these problems, because it needs people to lean into the problem and work with politicians and developers and builders and architects and all of us to try to try to bring solutions to the table.
Thanks.
And Jennifer Glass had a comment also in here about whether she can share your data in terms of the climate action plan that's being developed by the town about the 5% versus 1% on the renovation rate. I would imagine your answer would be yes on that.
Yeah,
and, I think further discussion on that topic.
Yeah, and it's not my data, it's Christoph Reinhardt's from MIT. So, but I think as long as you credit Christoph, he's given that presentation a number of times.
I'd love to see that presentation. I think we'll look up the data.
Yeah, it's on my slide. So when you guys have it, you'll see his name in the MIT lab.
And Mark and Colin, you're going to provide the PDF of this tonight, so, or not tonight, but I mean provide it. So we'll get it out to everyone who's on this, who's registered for this event, and also I think probably put it on the website if we can.
Yeah.
Michael, you had another question?
Yeah, quick question, Mark and Colin. How do you deal with mechanical ventilation in a mid-century modern home, especially deck houses, where there's just very little space to run ductwork, and how do you address that? I know it's a super complicated question, but if you got a quick focus on that, that'd be great.
Mark, I'll let you take that one.
Well, it's actually, I think with mechanical ventilation, the thing is, it doesn't have to be ducted to every room. And one of the things about a mid-century modern is that a lot of open spaces, how it's introduced into the space. You know, we usually work with a mechanical engineer on homes, because they look at the house as a plenum, and then they just figure out the right location. But it actually is not as complicated as you might think.
Okay. All right, good. Thanks.
I just want to jump back to Michelle's question for just a moment. And I really appreciate the idea of, and Mark, you're tying this together with public policy. I think that, you know, particularly in Lincoln, I live in Cambridge, zoning has made it really difficult to achieve density. And in my neighborhood in Cambridge, which is a predominantly two and three family homes, current zoning allows owners to convert their 2 and 3 family home to a single family, and the real estate market values that higher than the multifamily. And it feels like it's an area where there could be some good public policy that is preserves the housing units that we currently have at a minimum, and then maybe in Lincoln, figuring out how accessory dwelling units can more easily be included to kind of help. And Mark, you probably can do some analysis of the embodied energy, you know, in just infrastructure that exists.
Yeah.
If we can double our density as California has done, we can do a lot to save in terms of just rolling out more asphalt and paving over, you know, arable land.
Yeah, I mean, that ties into another area. If you think about E.O. Wilson and his half Earth proposal, you know, the density is an element of that. And I think real quick, Scott, I should give credit to John Sturman, I think, and Stan McChrystal for some of the thinking on carbon credits and public service, because those are two folks that I've spoken with, and I'm not sure if I'm stealing ideas from them, but I might be. So I want to make sure that that I give them credit in case I have.
Thanks. I think, you know, I'm for one, I'm looking forward to going back to the slides and pulling some of the data and understanding more. Yeah, it's an incredibly complex topic that we're all having to face today. And the more of us understand it, the better off we are. And I'm incredibly impressed with Lincoln in the way that the town has come together and been forward thinking in a lot of areas. makes me very happy to be moving there.
Yeah.
Are there any other questions? If there aren't, well, I thank you very, very much.
Wait a
Huge.
minute, we have one.
I have one comment to make, and that is that the air exfiltration is the function of the partial pressures of all the gases. And it's a combination of the nitrogen, the oxygen, the carbon dioxide, and the water pressure, the vapor's water pressure. When you take a shower, the vapor pressure of the water coming out of the shower is 10 pascals. And that drives gas out of your house. And that's why water is the most predominant form of escape of gas.
Ooh, excellent. That's one of the things I love about this is I learn something every time. I probably learned that in thermodynamics or one of those courses I took back in college, but I've clearly forgotten.
We learned it when we installed the windows. We get so much condensation going out.
Mark and Colin, one question that I have that might be able to answer is what other things that, I mean, I some of the things I've been looking at recently are data gathering and so forth, and some of the new things that are coming out to look at, use of water and so forth. But one of the things that really excites me is drain water heat recovery. I don't know if that's something you're seeing used more and more. I know it's been mandated in some places. I believe in some places in Canada, it's mandated.
So we haven't used it. I saw it probably the first time 15 or 20 years ago. And I think more important, well, a bigger change we've seen is the code on water fixtures or plumbing fixtures, and moving away from these 20-gallon-a-minute showers that were considered luxury. I don't have a lot of personal knowledge on the drain water heat recovery systems and how much they actually save. But again, if you're going from start, it's certainly something that can easily be introduced into a new construction project, or if you're replumbing. So these are the little things that just adding each one, there's almost no cost differential, and you pick up a little benefit. Absolutely.
If there aren't any more questions, I want to just thank everyone for coming tonight. Greatly appreciate it. And the nice part is with this recorded, Belinda has talked about the fact that it tends to be most people are watching after the fact and not watching live. But that's a good thing that they're actually watching and watching the recordings. So thank you very much.
Michelle has one more question.
Oh, Michelle, sorry.
No problem. Just related to the general concept of sustainability, not necessarily CO2 emissions, but sustainability. What about gray water systems and management of water usage, quantity of water used? How important do you think that is? How hard is that? Is that one of those things that is actually not too costly to do, that maybe should be a public policy change, that we require that for sustainability?
That's a tough one as well. And I think we did some analyses 2019. We looked at this for a couple of clients, and we really did a deep dive. And what we found was the changing nature of weather. So this is the more or the less frequent storms with the higher volume of water meant that the sizing of these systems to actually make a difference, they had to be very large, because you could go through periods where you have very, very, very little rainfall for 6 to 8 weeks, and then you might have a storm where you get 2 or 3 inches in a storm, but you have to capture so much to carry through those dry stretches. So I think this is a little bit of I think it's anything you can do to move in the right direction. And I would argue that nothing, I think Colin and I had this conversation over lunch one time where he did the math on the emissions of all the construction vehicles driving to and from a site. And I think, the reality is we talk about sustainability, but there's really nothing we're doing that is sustainable. And even this conversation tonight is about being less unsustainable. So I think that your question about rainwater capture would be, if you can put some in, that's better than doing none. And I think that is probably there's systems and solutions that we looked at for our clients that made sense. Neither client pursued it because they were looking for an all or nothing solution, but there was a scale at which it was relatively easy to add to the project and would have offset some of their water use.
And you see that as part and parcel of a gray water system?
And so when you're saying gray water, are you thinking
I mean, like
actual use
using-
collection from inside the house?
Yeah, from your
Yeah,
washing machine,
okay.
from your dishwasher, from your
Yeah.
taps, from,
So gray water systems, so we also looked at that. So I'm sorry, I misinterpreted your question.
no, it's okay because I care about water
Yeah,
preservation.
so gray water
basically.
systems are again, they can be used for irrigation purposes. And that seems to be the most effective way to use them. The International Living Future Institute has some good material on their website to look at. And also some resources that you can dig into. I think there it's the occupant's use again, that's being very conscious of how you're using water in the home. And then the other thing to keep in mind is that when you divert the gray water, you change the function of a septic system because you're reducing some of the effluent that ends up in the septic system. So again, it's just thinking about the system's effect of some of these things, rather than just jumping in, and pursuing a path without understanding the second order effects.
Thank you.
I actually tried a device when we bought the house in Lincoln. We found that it used 75,000 gallons of water in 9 months when no one was living in the house. And that was a little scary, especially since the group that owned it didn't notice it. But we put in a device to measure that right away. It was okay, but we're seeing several of those devices come out now that are coming out that are really looking interesting to actually be more cautious about knowing what your actual usage is on a regular basis and giving you warnings when you're getting a leak. The one that we used and tried that failed, but worked for a while, was a great device that actually warned us when we had a gasket on a hose that was bad because it was actually leaking at 0.1 gallons a minute. And I got an SMS message. So that was appreciated at the time, but more of those are coming out. If there are any other questions, we'll call it a night. And we can't thank Mark and Colin enough for all great presentation and thoughtful questions and answers to us. And this whole dialogue will continue.
I think Scott, if I could just add one thing.
Thanks,
I would
Scott,
point
and
people-
everybody.
I would point people towards the podcast that the series you're doing with Matt Reisinger on your own projects. I think there's a lot to learn by going through some of those resources. So I'd give you a little shout out on that front.
Thank you. I haven't made it very public in town yet, but it's been a fun project and it's had about 600,000 views so far. So it's pretty good.
Yeah.
Well,
Thank you very, very much to everyone and have a good night.
bye-bye.
Thank
Thank you.
you.
Take care. Bye-bye.
Bye-bye.